So good morning, good afternoon, and good evening to all our participants who have joined us across the globe and all our speakers for the webinar on electrical safety hazard mitigation at bus depots for electric vehicle supply equipment. Before we start the webinar, I would like to take you through the housekeeping rules. All the participants are requested to be on mute throughout the webinar. Also, please do not turn on your videos and microphones for a smooth webinar flow. And participants can share their thoughts and questions through the chat box only. Here is the glimpse of our agenda for today's webinar. We'll be having the welcome address and context setting by Ms. Reena Suri from India Smart Grid Forum. Welcome remarks will be by Mr. Siddharth Arora from Shakti Sustainable Energy Foundation. We'll be having a presentation on the report by Mr. Reggie Kumar Pillai from India Smart Grid Forum and Global Smart Energy Federation, followed by the panel discussion, which will be joined us by from the speakers, Mr. T. Surya Kiran, ASRTU.
No.
I would like to request all the participants to be on mute, please. Thank you. We'll be having Mr. Sachin Talavekar from MSc DCL Pune, Mr. Shahzad Alam from Solvina, Mr. Sameer Pandita from BEE, and Mr. Devrata Guha from WBTC. And the panel discussion will be moderated by Mr. Ravi Sitapati, Chairman Viceres and Working Group Chair, India Smart Grid Forum, with the vote of thanks by Mr. Reggie Kumar Pillai. So without any further ado, I would like to invite Ms. Reena Suri, Executive Director, India Smart Grid Forum, for the welcome address and context setting. I would like to give just a small brief introduction of Reena ma'am. Reena ma'am has over 20 years of experience in the energy sector and is responsible for the research projects, advisory services, business development, training and capacity building programs, customer outreach activities, members relations and finances of ISGF. So over to you, ma'am.
Thank you so much, Parul. And with that, let me once again a very warm welcome to our participants, speakers, panelists to this webinar, a very unique webinar where we are going to talk about the electrical safety hazard mitigation at the bus depot for electric vehicle supply equipment. So thank you all for joining today's webinar. We are very delighted to have such a diverse group of experts and panelists with us today. Let me start with providing a brief introduction about ISGF. Most of you are familiar with us. For those who are new to ISGF, a quick intro. ISGF is a think tank of global repute on smart energy, electric mobility, and smart cities. ISGF was established in 2011 and has been by Government of India and has been spearheading the mission to accelerate electric grid modernization and energy transition in India. ISGF is registered as a not-for-profit society, and we are based out of Chanakyapuri in New Delhi in India. We have a mandate to advise the government on policies and programs for promotion of smart grids, e-mobility in India. We work on national and international within national international agencies on standard development to help the utilities, regulators, the industry in the strategy development, technology selection, training, and capacity building of the and skill development of the sector and the official workforce in India. ISGF has also been working with the electric distribution companies in India to accelerate the adoption of the innovative smart grid technologies, including renewable energy, electric vehicle, working on with the utilities for integration of these new technologies with the electric grids, and have partnered with large number of technology providers and entrepreneurs from around the world to introduce emerging technologies in India. So to achieve this goal of new technologies coming into the sector and the sustainable energy goals that have been set up by the government under the climate agreements, and India has started its journey towards the electrification of transportation, greening of the transportation. in the next 4 to 5 years, we see that India plans to roll out 50,000 electric buses and a huge plan of electrification of all the different transport modes that are available. But for particularly talking about the electric buses, huge numbers are coming into play, which will necessitate the megawatt scale power connections at thousands of bus depots around the country. And currently, India's distribution infrastructure is not capable of handling such a power demand, necessitating careful planning, grid strengthening in collaboration with the various transport departments, bus fleet operators will be required. So detailed studies will be required to identify the extent of consequences of electric vehicle charging loads on distribution grid and estimate the mitigating measures that are required to be implemented in conjunction with the installation of the electric vehicle charging infrastructure for the bus depot that is coming into place. So with this brief background, I won't go into the details. I'll have all our experts also talking about it. Mr. Pillai will be giving a brief theme presentation around the intensive study that ISGF has done. So we have conducted a extensive study around on the electric safety hazard mitigation at bus depots for the electric vehicle supply equipment. And this study was implemented with support knowledge inputs from Shakti Sustainable Energy Foundation. We had necessary support from the Pune Mahanagar Parivahan Mahamandal Limited as one of the component of the study was in Pune, and we thank them for that. We also had extensive support from the West Bengal Transport Corporation. Mr. Guha will be talking about that with us. He's there with us. Thank you for joining us, Mr. Guha. And Maharashtra State Electricity Distribution Company provided their support in the study, and Mr. Sachin Talevar has joined us from MSc DCL. Thank you, Mr. Talevar, for joining us. And CSE Calcutta has also provided their support. Unfortunately, their managing director is unable to join us. And Mr. Ravi Sitapati, our advisor and executive chairman of VISRUS, has also joined us, and he has been guiding us and has provided his support for undertaking this study. And Solvina India Private Limited has worked with us, provided the power quality meter, and helped us with the data required for the study. And we have Mr. Shahzad Alam, who has joined us from Solvina. Thank you so much, Mr. Alam, for joining us. And Electra also has the Green Tech Limited has also supported the study with us. And with that brief introduction about the study and all the support we received from different stakeholders for the study, let me also welcome Mr. T. Surya Kiranji, the ASTRTU, for joining us here. And we have Mr. Sameer Pandita, Director, Bureau of Energy Efficiency, was joined us today. Thank you so much for joining. I understand Mr. Pandita will be more in the observation mode. But we'll love to have your inputs for during the webinar if you would like to provide. And also, as I mentioned, Shakti, being Shakti Sustainable Energy Foundation as our knowledge partner, and we have Mr. Siddharth with us. Thank you for joining us. With that brief welcome, I really would like to thank everyone once again for joining us today. Throughout the webinar, we'll be looking forward to exploring, the outcomes of the study with the experts that are with us here with us. We'll be dwelling into the various aspects of the safety hazards that we will be looking forward to, with this kind of huge electric demand coming from the buses that will be connected to the grid, and we'll be looking forward to their valuable perspectives. We encourage all our participants to actively participate, ask questions, share your thoughts during the question answer round and discussion segment. And hope this webinar is informative, engaging, inspiring for everyone. And we take most of this opportunity to learn from the experiences that we have, that our experts are bringing, with them today. So with that, thank you and a warm welcome to all of you, and over to you, Parul.
Thank you so much, ma'am. With that context setting, I would now like to invite Mr. Siddharth Arora for the welcome remarks. Mr. Siddharth Arora is Associate Director, Clean Power, at Shakti Sustainable Energy Foundation. Mr. Arora has over 10 years of experience in the domain of renewable energy, energy transition, electricity regulation, and sustainable development. And prior to this, Mr. Arora has also worked with Maharashtra Electricity Regulatory Commission as a senior regulatory officer. So without any further ado, I would like to hand over the stage to Mr. Siddharth for the welcome remarks. Thank you.
Thank you, Parul. Thanks a lot. And thanks, Reena. I understand everybody is quite eager to know the details of this study and delve into that. So I'll keep it short. Just about Shakti, we are a philanthropy-based organization, and we are situated at Delhi. We work with very closely with various ministries, and our objective is to have India's clean energy transition. And we work with MNRE, MOEFCC, BE at state level also. Like we work very closely with the state of Bihar and Tamil Nadu. Now we are also looking for some engagement with Gujarat. And on sector specific, power sector is one key area, and we also understand that transport, electric mobility is also an issue which needs to be understood carefully if we have to develop our net zero pathways for 2070. I'll like to thank ISGF also for this opportunity given to me. And I'll also thank and welcome to all our panelists who are here today, and the moderator, Mr. Ravi Sitapati. I welcome Mr. Guha, MD, not MD, sorry, he's from WBTC. Mr. T. Suryakiran, ED, ASRTU, Mr. Sachin Talewar, MSc DCL, Shahad LMG, MD, Solvina, and Mr. Samir Pandita, Director, BE. As already briefed by Reena, that there are about 50,000 electric buses to be deployed in next 4 to 5 years, and we need to understand all the challenges which will be there, and yeah, and we know that probably the distribution network is not strong enough to take so much distributed megawatt scale deployment of electric buses or the charging stations. So we need to understand various technical interventions which are required. We need to understand on the harmonics, and I would like to congratulate ISGF for this wonderful work which they have done, and probably it will be an enriching journey today, next 1.5 hours as we go into the discussion. So thank you once again, and over to you, Parul.
Thank you so much, Mr. Siddharth. So now I would like to invite Mr. Reggie Kumar Pillai, President India Smart Grid Forum and Chairman Global Smart Energy Federation, for the presentation on the report on electrical safety hazard mitigation at bus depots for EVSEs. Sir, are you there with us?
Yeah, I'm very much there. Good morning, good afternoon, good evening to all the participants, and thank you very much for your interest in joining us for this webinar, where we are going to present the key findings of this first of its kind study, which is undertaken anywhere in the world. We have installed 2 power quality meters in 2 bus depots and monitored the real-time measurements of the power quality meters for almost 1 year, from August 2021 to 22 August. So it's a very unique study which has been done. I will share the a few slides, and then we move to the panel discussion. My screen is visible, Parul?
Yes, sir.
Yes, sir.
So we have conducted several studies on electric mobility starting from 2014 onwards, and the detailed study we had done in Calcutta, electrification of public transportation in the city of Calcutta, which was one of the very comprehensive study we have done in 2017. 16-17 time frame, and one of the main thing came out of the study was right sizing the battery of electric buses. Until 2016, the buses which were being introduced in India had large battery sizes of 300 kilowatt hour or above, which did cost 2.5 to 3 crore Indian rupees, which were unaffordable. All the studies conducted prior to that written that we need a large amount of viability gap funding, 50% of more of the electric bus cost. Otherwise, these buses are not going to be viable. So we have seen in our study that in Calcutta, the buses which are running are typically 100 kilometer per day and doesn't need 300 kilowatt hour batteries. And we have done cost benefit analysis with 100 kilowatt hour battery and 200 kilowatt hour battery and 300 kilowatt hour battery. And we have seen that for 100 and 200 kilowatt hour batteries, no viability gap funding is required. Accordingly, we recommended, and we are very glad that the West Bengal Transport Corporation and the government of West Bengal had agreed to most of the findings, and they had entrusted ISGF to make the specification for electric buses with a 120 kilowatt hour battery for 9-meter buses and 180 kilowatt hour battery for 12-meter buses. And when it was put for bidding, the price of electric buses came down below 1 crore rupees. That was a turning point in bus electrification in the country. And thereafter, every bus operator started asking for buses with the appropriate size of battery for their need, rather than what is being pushed by the OEM. And today there are about 2,860 electric buses in operation in India, and government plans to roll out 50,000 buses in next 4 to 5 years, and this would require megawatt scale electricity connections in thousands of bus depots across the country. In congested cities, providing megawatts connections could be challenging. It requires major upgrade to the distribution grid, and that must be planned in close coordination between the electric utility, the bus department, the city municipality, fleet operators, etc. And this is something which has not happened in the past. Bus depots never wanted connection more than few kilowatts or tens of kilowatts for their lighting, fan, and small machinery and cooling. And they never looked at a megawatt scale, and they don't understand the complication of running a megawatt scale power distribution system within the bus in a bus depot. And electric utilities never considered bus depots to be a major customer for them in the past, because they always taken 30 kilowatt or 50 kilowatt connection. So now all on a sudden they are coming and asking for 5 megawatt, 10 megawatt electricity connection. So this is something which is happening for the first time. And we, in this particular study which we have done, Pune was one of the PML in Pune started with electrification of their bus fleet, and bought more than 100 electric buses in 2019, and the majority of the buses were put in one large depot, which is Bakarai Nagar bus depot, and where they have taken a 22 kV connection from the distribution company, Maharashtra State Electricity Distribution Company, and they put their own package substations there and started connecting, charging the buses there. So this was the first such experiment which happened in 2019, and now thousands of bus depots around the country will do this. So we have taken note of this and started the study in 2021. So the main objective was to design electric network inside the bus depot appropriately to avoid accidents while charging of the electric buses, avoid idling of the electric bus owing to impediments in charging, thereby lost opportunity in abating GHG emission from transport sector, mitigate impact of EV charging on the electrical network, and avoid difficulties to other customers of the utility, ensure safety of O&M personnel in the bus depot, etc. And we installed 2 power quality meter, one in Bakrai Nagar depot where there's a megawatt scale charging system in operation, and also at a lake depot of WBTC in Kolkata. The assess the impact of electric bus charging on the distribution grid from the power quality meter reading from September to August 2022, modeled the electrical network in 2 bus depots, and conducted load flow studies for various scenarios of charging load in 22, 24, and 27. We analyzed the need for active and passive harmonic filter and other mitigation measures, standard operating procedure for EVSE installation and commissioning, operation and maintenance, recommendations, etc. And we conducted stakeholder consultation to disseminate these findings. And today we are happy to present this study reports to the wider cross-section of people from around the world. So what we did in Pune, Bakrai Nagar, is as I said, they have taken a 22 kilowatt connection from MSCDCL, and the 22 kV panel in the bus depot has 5 outgoings, each going to a separate package substation, where 1250 kVA substations, 22 kV by 415 volt substations are there, from where they are connecting to different number of chargers. There are 5 DC chargers and 58 AC chargers of 80 kilowatt capacity, which has 2 guns of 40 kilowatt each. This is what is currently existing there when we conducted the study. And the power quality meter which we deployed for this study is a Metrum make PQM 140 class A from Sweden, and this was taken on lease from Solvina. And this is a meter which we have the connection diagram, etc. we are depicting here. And what we have observed is that the standard which we referred is EN 50160, used for the power quality study and analysis. So we have found that the voltage variation, total harmonic distortion, individual harmonics, voltage imbalance, these are all within the limits prescribed in EN 50160, flicker, frequency signaling, etc. But we have also found voltage sags, which happening very frequently. There are more than 400 voltage sag happened during this period, of which 65 sags were below 60% of the normal voltage. So according to SEMI F47 standards or regulations, these sags which are below 60% have very higher severity level and have the potential to damage electronic and semiconductor devices in the nearby area connected to the grid. These voltage sags were actually induced into the distribution network from upstream, and typically we understand it's come from the transmission grid, and this need investigation. It's recommended to install class A power quality meter monitoring system in all such large bus depots. And also we have found that currently the maximum load in this depot, Bakrai Nagar depot, is less than 50% of the capacity. And if the capacity of the loading of the charging loading is going to be increasing, the 58 plus 5 chargers which I mentioned, if it is going to be substantially higher, there could be issues on power quality, which is not there as of now, which is a good news. And this is some of the scenarios which we studied with the model which we created, the load flow model. Case A, RC scenario, all the EVSE is connected, and we performed the load flow analysis as of 2022. And we also modeled the data based on a real-time recording captured by the power quality meter. So that is in the case 2. And for 2024 and 2027, we assumed higher charging loads, and we looked at it, the number of under voltage and overload elements we have looked at it. And these are some of the harmonic analysis of different scenarios, which are, as I mentioned, are all within the limits of EN 50160. So nothing as of now serious about it, which is good news. And but at the same time, all these megawatt scale connections need constant monitoring and studies. And what we did in Lake Depot in Calcutta is that there are only 8 electric buses of 9-meter length are being charged there. They have 7 electric vehicle chargers, DC chargers of 60 kilowatt and one with a 120 kilowatt charger. So, and they have a 500 kVA distribution transformer, and this is the connection diagram which is there currently existing. There will be more buses which will be added in the next phase of 1180 buses which WBTC is planning to deploy very soon in the coming years. The CAC Calcutta is the electricity distribution company there. They are giving a 11 kV supply they are bringing to the next to the bus depot, and they are giving 3 feeders from the distribution transformer, and which are in a meter room, very well made meter room. And key findings here again, here the actual meter reading we've been capturing real time in a server in ISGF office. We had some communication trouble in the beginning. So from December 21 to August 22, we have complete data without any interruption. So this again we compared with the EN 50160 standards, voltage variation, total harmonic distortion, individual harmonics, voltage imbalance, frequency signaling, flicker, all these are within the limits of prescribed under the standard. The voltage sags, here again we have noticed most of them are within the limits according to the EN 50160, but there are some voltage sags, actually 28 sags out of 130 sags were below 60% of the normal voltage, which is as per the SEMI F47, these have potential to damage electronic and semiconductor devices. So another serious thing which we noticed in Calcutta is rapid voltage changes, which were observed in, and many of them were outside the limits prescribed by EN 50160, which require more detailed studies. So RVCs we have not seen in Pune, but we have observed RVCs or rapid voltage changes in Calcutta, and these are most of the RVCs observed were beyond the limits prescribed by EN 50160. So the load profile observed at the PQ measurement here also is less than 50% of the total capacity. So however, if the loading increases, there could be power quality degradation issues which need constant monitoring. So here again we have done the distribution network inside the power the bus depot. We have modeled the different scenarios we have modeled on the network and found most of them within acceptable limits as we speak. And the details of all this will be available in the report which we will be uploading in our website, and also sent directly to all the registered participants of this webinar next week. We would like to take the input from this webinar as well and the comments, and finalize the final report which we will be publishing next week. So the key findings from the whole thing is that load flow study results of 2022 scenarios and the PQM measurement have been compared and found to be in alignment. So what the different scenarios we have modeled, as well as the power quality meter measurements found to be in alignment, and also scenario studied for 2024 and 2027 assumed additional EVSE loads beside the normal load growth and found voltage sags and harmonics beyond acceptable limits in those scenarios. The EVSE load growth assumed for 2024 and 27 could not be verified by the relevant stakeholders. So we did not actually estimate the measures, mitigation measures for harmonics in that scenario. So it is advised that when EVSE load is enhanced in the bus depot, detailed planning studies may be undertaken to estimate the type and sizing of harmonic filters to be installed in the bus depots. So the recommendations for electric utilities is that wherever you are giving a ST connection, 11 kV, 22 kV, 33 kV connection to a bus depot and other public charging stations, detailed engineering drawing along with equipment sizing calculations of the electricity distribution network within the bus depot must be verified and approved by the utility before sanctioning ST connection. So equipment sizing need to be properly studied, and appropriate system should be in place inside the bus depot before the connection is given. All electrical equipment installed inside the bus depot must conform to relevant BIS and IEC standards, which must be checked by the utilities. The site engineer in charge of the charging station in the bus depot should coordinate with the local utility engineer at the respective substation from where the HT connection is given, and must have the site engineer in charge of the charging station should have minimum training on operation of numerical relays and protection systems. This is a must. Please ensure that is done. And power quality meters which can record voltage and harmonic profiles must be installed in all EV charging stations with more than few hundred kilowatt of load given. And the readings may be monitored in real time, and history of the recordings must be maintained for a mutually agreed time period. So the recommendation for the bus operators are distribute the charging load on different locations to reduce the harmonic effect on the grid. And also it's good to have more chargers in different depots. In case any problem happening in one depot, buses can go to another depot and charge. And package substations and EVSE must be installed far away from the passenger boarding area. Charging station in bus depot should have fire extinguishers and smoke detectors installed. There should be clear evacuation procedure in case of a fire. Staff should be provided with the appropriate personal protective equipment. Chargers must be installed on pedestals high enough to protect from flooding. Ensure water does not go inside the chargers, which could lead to fault. Adequate illumination in the charging area to be ensured when natural light is low. Distinct way marking for parking of electric bus to be provided in bus depot, preferably marking with fluorescent paint. CCTV to be installed to monitor charging area 24/7. Unauthorized access should be denied in the charging area. In case of an emergency, there should be clear protocol in place to shut down charging equipment and isolate the battery. So these are a set of recommendations. We have given the more detailed standard operating procedures in the report, which you all will get it when we release it next week. Thank you very much for the patient hearing. Back to you, Parul.
Thank you so much, sir, for the detailed presentation. We will now be moving forward with our panel discussion. And here is the glimpse of our speakers for the discussion. Joining the discussion, we have Mr. Debabrata Guha, Senior Engineer, OHNC from West Bengal Transport Corporation. We have Mr. T. Surya Kiran with us. Sir is Executive Director, ASRTU, and has an experience of more than 30 years in road transport industry in various areas like operations, personnel management, traffic management, and planning and marketing, etc. in Andhra Pradesh and Telangana state. We have Mr. Sachin Talavekar with us, Chief Engineer, Maharashtra State Electricity Distribution Company Limited. And Sir has a history of working in transmission and distribution of electricity and has the experience as head engineer with a demonstrated skills in power systems, energy engineering, business development, and project engineering. Mr. Shahzad Alam has joined us. Sir is Managing Director from Solvina and has more than 29 years of experience in the power sector from project execution to operation and maintenance. We also have Mr. Sameer Pandita with us, Director, Bureau of Energy Efficiency. Sir will be in more in the observatory mode for today's webinar. With over 20 years of experience in the field of energy efficiency, Mr. Sameer has played a key role in shaping policies and programs aimed at reducing energy consumption and promoting sustainable development. The panel discussion will be moderated by Mr. Ravi Sitapati. Sir is Executive Chairman of Bioceres Incorporation Canada and a Corporate Director of Larsen & Toubro's Power Transmission and Distribution, India. Sir also serves as ambassador for the Americas for the Global Smart Energy Federation USA and advisor to India Smart Grid Forum. Sir has over 35 years of experience in the energy and power systems area in Canada, and Sir mentors several utilities and companies in their technology and development. Before handing over the stage to Mr. Sitapati, may I request all the speakers to kindly turn on their cameras for a group picture. I would also like to request all the participants to kindly turn off their cameras.
I think the group picture with the participants we'll have in the end.
In the end, yes.
But right now we'll do a group picture with our panelists.
Thank you so much, ma'am. Thank you so much, sirs, for the group picture. So without any further delay, I would like to request Mr. Ravi Sitapati to kindly take the panel discussion forward. Over to you, sir.
Thank you for that warm introduction, and Reggie and Reena for your opening comments, and Siddharth for your support. I have very fond memories and very late night discussions beginning from Kolkata. In fact, Reggie will remind you of her hotel stays in Kolkata when we began this journey, thanks to the Shakti Foundation as well, where we began to examine why we were paying what we were paying for these buses, why we should not have rate increases with electricity, your bus charging. And it was a very good optimization study whereby the electric utility did not have to spend extra money. We did not charge extra bus tariffs. We gave them air-conditioned buses, which are electric vehicles. And we were able to prove that India had a solution for many, many parts of the world as opposed to what the OEM was pushing. So very fond memories of that. And then again, we repeated that ahead of the curve by meeting with the mayor of Pune. Thanks to Reena who arranged that meeting. I happened to be in Pune and she arranged that meeting. When the first tender for Pune was coming out. So the questions raised by the mayor were, what are the problems in other parts of the world? And what would be the potential solution for that? So there are very good interactions that ISGF has had even before the journey began in a very big way for many people. And this report to me also outlines that, again, that advanced study. And again, I thank Shakti Foundation for that. There seems to be a congruence, in fact, between ISGF and Shakti Foundation in exploring new territories. And I think it's a very good report. It's a beginning. I won't say this is the end. In fact, as India begins its journey, there are many, many more items to be discovered. But let me talk about 3 buckets. I've had a sneak preview of the report, having been involved. So there are 3 sort of buckets which perhaps later on can be taken for further or explored even amongst the recommendations of this report. The first is, Reggie mentioned about voltage dips. Actually, there is another area to be examined. When a charger gets shut down due to voltage dips, because the voltage falls below 90% or 80%, it does not restart by itself. We've had issues around the world where the charger just sits there not charging till somebody comes and restarts the whole process. So this may not be a big problem for the bus depot chargers because they have somebody there 24/7, but it could be a very big problem for the consumer end of it or parking lot type devices, the L2 chargers especially, where people think that they have put it to charge, there's a dip in the night, people are all asleep, and next morning they find that the car is not charged. So it should probably be in the standards about this right through. There is a mention in the report about the right through, but I think we need to ensure, like we did for inverters, solar inverters, in the IEEE 1547, we need to bring that in even here for that, to say there should be a right through mechanism. The second is very interesting between constant current charging and constant voltage charging. Constant current charging, as per the report here, says there's less harmonics. But constant voltage charging towards the end, when the battery achieves its 85% state and moves towards the 100% state, it moves to constant voltage charging, and therefore the harmonic content is higher. Again, the question is, for better optimization of charges, especially in the bus depots, do we just do up to 85% and leave it? Or do we have to take that extra 2 hours and do a full charge? It's something, again, it's a business proposition. In many parts of the world, we just stop at 85, which is also good for the battery, by the way. And so we just stop at 85. We do from 20 to 85 and then leave it at that. But those are all discussions to be had. I think the other part is wherever full bridge diode thyristors are used, which are cheaper than full bridge diode bridges are used for rectifier, as opposed to thyristors, we see a larger harmonic and an offset. This is just because of the circuitry. I mean, there is nothing you can do. A thyristor, on the other hand, which is more expensive, is perhaps going to give you a cleaner output than the cheaper diode bridges, which are, basically just rectifiers, right? Uncontrolled rectifiers. So I think that is another area on standards where maybe we should, as India proliferates in its electric vehicles, we should start using the specification for thyristor-based bridges as opposed to diode-based bridges. The unbalance has been mentioned in the report, in the recommendations. And I think going forward, if we don't solve this unbalance issue within the grid, the neutrals, which is 3.5 core neutrals, will all have to become 4 core neutrals. In fact, my view already is that in new standards, it's be good to have the neutral as a full core as opposed to a half core, because in many places it starts heating up. And when you have heating up of the neutrals, then the whole power system is vulnerable. So it's something to think about. Also, the coefficient of grounding, if your star point neutral is not completely grounded as per standards, and give you a coefficient of 0.9 and higher, your neutral star point will begin to shift. And when it shifts now, it becomes almost operating as an ungrounded system. So you could have very high over voltages in the non-loaded areas of the phases, which could be another potential threat going forward. So I think some of these we need to sort of worry about in the future as we proliferate. But the utilities and as well as the bus depot operators have to be cognizant of this, simply because you are in this together. There is, prior to all this, the transport was very distinctively different from electric utility. But now everything is coming together, and therefore all of them have got to be singing from the same song sheet. So with that, I'm going to sort of turn it open to the panel. I think I'm going to give each one of the panelist members their opening remarks, whatever that they like to see, what have they seen, is there anything more that they would like to add, do they like to defer on any of the comments made by any one of us in the beginning, so on and so forth. So I'm going to begin with Mr. Debrata Guha. Mr. Debrata Guha, the floor is yours.
Good afternoon, everybody. Can you hear me?
Yes, we can hear you.
Now, it feels nice that Smart Grid has arranged for this webinar, and they are placing the report of the study that they have gone through. WBTC is presently operating 80 electric buses since 2019 and around 20 for last 1 year in addition to that. Now, before induction of these electric buses, ISGF happened to make a comprehensive study in 2017. I think Mr. Ravi was referring to that study itself. That was a very comprehensive one, covering all types of the modes of transport that the city of Kolkata has, be it auto rickshaw, tramways, ferries, buses, taxis, etc. Now, with that study as a guideline, we placed the tender and we discovered a very magnificent rate for our buses. And since then, we are now running for the last 4 years. We are in the process of inducting around 1,200 more buses, which is expected to hit the roads by this year itself. And with induction of those buses, the total transport scenario of Kolkata will have a paradigm shift. About 50% of the public transport may be seen to be electric. We presently are planning exhaustively for the charging systems, the depot locations, the routes, etc. It's almost been finalized, and it's pertinent to mention that ISGF has been assisting with us and the DISCOMs in this aspect also. Now, regarding this mitigation of safety hazard, specifically electrical safety hazard, till now we have faced very small adverse situations. Most of the time, it was in the initial stages, we face certain problems, mostly with charging the buses, their synchronization, and occasional failure of the one or more phases. But at present, since last about 2 or more years, we have been running them consistently without any interruptions. Now, with this, I would just like to hear from the experts regarding this electric safety, what we have to follow and how to mitigate the probable hazards. Thank you.
Thank you, Mr. Goha. I'm going to turn over to Mr. Nauti Surya Kiran. Mr. Kiran, the floor is yours.
Good evening to all of you. It's really nice to see that such a report has come out and such an effort has been made to make almost a year collecting data, preparing a report, and now we are letting it out to the world, see this. It's a really requirement of the day. Not much has been going around in this area, especially when electric buses are really going to proliferate. If you look at the entire country as of today, there are over 3,600 buses on the road now. All these 3,600 buses are being operated by more than 33 public bus transport bodies in India. And specifically, out of these 3,600 buses, just about 100 and 150 buses are in the intercity operation. Otherwise, the entire lot is in the smaller cities and the bigger cities in India, where electricity is available and proper assistance is given to different depots through DISCOMs, and it has been set up. Till today, like all the entire public bus transport in India is diesel dependent, or at the most CNG. So it is 12,000 buses are out of 150,000 buses in India. CNG, there are 12,000 buses, and the rest of 130,000 are in the diesel-based buses. So entire system is used to operating on the diesel buses. The ease of operation in diesel is definitely there. Because diesel is available. I mean, the HSD is available everywhere. There, it's within the depots and outside depots. So that wasn't dictating the schedule of the buses itself. That is how you operate buses, the pattern of operations of the buses. Once electric buses have come in, now the charging is actually literally dictating the way the buses to be operated. Because of the range constraints so far, now only we're just overcoming the range constraints. Operators, manufacturers are coming up with higher range buses, which can kind of improve the entire system. Otherwise, it's like a lot of challenges have been faced. Or now further, it's going to be more challenging for more STUs, because in the pipeline you have more than 16,000 buses to be coming into this country. They're already in the pipeline now, and expected to go up by another at least 10 to 15,000 buses in another 1-2 years through CSF tendering or through various other processes. Probably some of the STUs are opting for their own tender systems. And the manpower availability in any of these depots, not at all either qualified or not trained or know the intricacies of managing electric buses. These 3,600 buses are being operated at the moment in different cities. It's a learning experience. There are very few STUs, something like WBTC or PMPMA, PML, or somewhere in Telangana or BEST, there are early operators who've been there almost from past 2 to 3 years. They have learned something, but the word has really not spread across the country. There are a lot of things happening in these electric bus operations in all these cities. We are really facing some of the dangerous situations like fire accidents are happening, which are really not reported though, because they're not very damaging as yet, to say so. Emergency situations have not nearly arisen, but when you look at the quantum of numbers which are going to come up in the future, things are really not going to be so easy to manage. And when I'm seeing the recommendations are so good now, we'll definitely have to take up all these recommendations and go on to spread the word across the country to every STU who is going to be the mainstay of electric operations. It is for the timing. Though Moth is trying to bring in private operators into, electric buses through the private operators also, but I think it's going to be far short as long as the charging stations don't happen across the country. Private bus operators is not going to be easy because building up charging stations for themselves is going to be very expensive. Even for STUs also, to have a depot providing upstream connection to each of the depots is also very expensive, which is actually right now no one's paying. So the STUs are facing the brunt of spending those monies. So there are a lot of challenges. There are a lot of research work required so that the entire system stabilizes quickly. People across the country, more than almost we have about 150,000 buses operating. Around that means about 7 lakh employees around in public transport units itself are there. They need to understand the intricacies of operation. Everyone has to understand the intricacies of operation, be prepared to face challenges, and also ensure that we don't get into challenging situations through such recommendations. Getting implemented prior to entering into electric operations. And also SOPs have to be released. I've seen the SOPs also being mentioned in this report. That's very interesting. We should also spread the knowledge. That's the main thing. And I'd stop it here and then we'll discuss further. Thank you.
Thank you. Thank you, Mr. Suryakaran. Mr. Suryakaran. Next, let me open the floor to Mr. Sachin Talewar. Mr. Sachin Talewar, the floor is yours.
Sir, he is not here. We can go ahead with Shahzad Alam, sir. Okay,
Mr. Shahzad Alam, the floor is yours. You've been a party to this experiment, so you would know.
Good afternoon, good morning to you, Ravi Saab. Good afternoon and good evening to the rest of the panelists. Since we were a party to this exercise, I would like to point out from the report, you must have noted, Ravi Saab, that we had a lot of RVCs, rapid voltage changes in Kolkata, whereas we could not find any in Pune. It was more because the PQ meter that was installed was at the 22 kV incomer transformer, and at Kolkata we had at the 230 volt feeder. And so we had a transformer in between, and so RVC could not be acquired by the PQ meter. And the point that I want to raise is that in future measurements and exercises, if any, we will need to monitor at both ends so that we get as much information as is possible. You knowing fully well the importance of the impact of rapid voltage changes on electronic equipment, the charger and the rectifier being one of them. And if it gets damaged and shut down, you know that things have to, the whole exercise will be, you'll have to put in a lot of other efforts there. Apart from that, as pointed out by Mr. Reggie, we had the loading pattern was still low. We expect once it goes high, we will have far more PQ parameters to be taken care of. Harmonics could impact. Also, one important aspect that we have been seeing is while mitigating the third, fifth, and seventh harmonics, we have seen in other measurements that 21st, 27th, and 29th harmonics are being, you could say, we are seeing the impact of these harmonics, and this could in future may impact, and so we should take this into consideration during our future research activities that we do. And you rightly pointed out, sir, that we need to think about the neutral, the distribution system. In most of the places are weak, and 3.5 core cable will not do the required job. We'll have to probably shift to 4 core cable. And with my experience in condition monitoring, we have seen that even the neutral gets heated and burnt out, and we have a lot of cable termination problems, which we have seen in the field. So with this, I'd like to hear more from you all. Thank you.
Thank you, Mr. Alam. Reji, I'm going to bring you in here. Now that you have sort of seen the report, read the report, and heard the comments, would you like to add anything here? And then we can start a discussion. Is Reji there?
Yeah, I'm there. Very much there. I was on mute. Well, good. We have a couple of other participants who has last minute been called up in other meetings. So that I expect Mr. Talavar to join in a while. As far as the study and report are concerned, as I mentioned, there will be thousands of bus depots where megawatt scale connections will be taken, and they all need to go through such studies. And currently we are doing a project along with WBTC for deployment of 1180 electric buses, which they plan to house in 14 different depots in Calcutta city. And each of these places, there will be 4 to 6 megawatt electricity connections. And detailed planning study we are doing from which substation of CESE this can be given at the most appropriate or with least capex for grid upgrade. And also, once the connection given in the depots, what is the standard? Some of the depots will have 70 buses, some of the depots will have 100 buses, some of the depots will have 120 buses. A standard template we are trying to do out of that, a depot with 100 buses with say 20 chargers. 20 chargers, say 240 kilowatt in 20 chargers, and 100 buses in a depot. What is a optimal power distribution arrangement within the depot with all the safety procedures and precautions? What kind of a template we are trying to make? A 50 bus depot, 75 bus depot, 100 bus depot, 125 bus depot. That kind of a different templates will evolve from the detailed study we are doing with WBTC in Calcutta. That could be used by other state road transport undertakings who are embarking on thousands of buses, electric bus deployment.
Thank you, Reji. Is Mr. Arora still online here? Siddharth Arora from Shakti.
Yes, sir, he is here only.
Mr. Arora, can you hear us? There it is. Mr. Arora? I can see him. I can't.
Yes, sir. So I'll just check.
Yeah.
No, that's okay.
Anyway,
He's also a party to this, right? And so before I move to the next phase of the discussion, I wanted to seek his input because he would have also a more social, community-oriented input as well, which I have. By the way, having listened to Mr. Surya Kiran, I have 3 questions here, in fact. He's generated some good discussion. The first question for you, Reji, is this. You know, with manpower, we had the same problem, in fact, in the early 80s when I came here, right? The notion of controls, electronics was not there. It was largely power, relaying, protection systems, etc. So, in fact, my first task was to create what was called a CNI group, controls and instrumentation group. And that took quite some time. In fact, we had to separate the trade technologist from electrical power to what we called control and instrumentation. Thermal power, by the way, has it. In fact, it's a part of their legacy to have a C&I group within their electrical department. But utilities don't have it. In fact, even today, if I was to look at C&I in most utilities, it will be lacking. Okay, it just doesn't exist. Even though relays have gone digital, the C&I aspect of it is still lacking. And my question here is even further. With EVs, you actually need those C&I people at the bus depots, at the various manufacturing, testing, even within the Bureau of Energy Efficiency, you'll probably need these folks. Everywhere it is C&I. And so the question is, how do we bring that capacity and capability up? And I thought if Mr. Arora was here, Reggie and he can answer together with inputs from the other panelists. Because to me, this is a big lacuna. Everywhere you go, you see good power engineers, even though they're all aging, but you see good power engineers. But you don't see good C&I engineers coming forth to be in the power sector side. They're all in the other small power electronics, but they are not into the heavy power electronics. So, Reggie, do you have any comments on it?
Yeah, I mean that's a main lacuna in we now the new teams which they are trying to recruit are also mostly IT. Most IT people, computer science people are joining utilities, but not control and automation people, not many coming in. It's a problem.
Reggie,
It's
I
a true
think
problem. Can you hear me?
Yeah, we can hear you, but there's also some background discussion somewhere else. So, okay.
Not here. That's not here. We are all in a meeting room. And another interesting point which you raised about this manpower issue, bus depots. Bus depots are going to all the bus operators and bus depots. They need to have power engineers, which they never thought.
Right.
They need to. If they have to take megawatt scale connection, have power distribution arrangement within depot and manage that safely and reliably, they need to have power engineers in all the, for all the bus operators in all the charging stations or bus depots. That's a new area, a new set of skills.
Reggie, can you hear me?
Yes, Balasar. Oh, you are there.
I'm
yes,
there.
sir.
Just 2 points. One is what Ravi mentioned about 3.5 core. Utilities are now all started using 4 core for quite some time. That's number one. Number two, in terms of power electronics into EV, the best way is to bring in the OEMs into it and give them a wraparound contract, like how we did it when we took over Delhi. Over.
No. See, as you know, you know about Pune, who is running the show? It's the OEM only running the show. In FAME 2 program, most of the buses are going to be run by the OEMs only. So, but again, their understanding of this power systems are also very limited. Megawatt scale connections, nobody has handled at that level. So they also need guidance and trainings.
I think Ram makes a good point, right? What Ram is trying to say is to bring up capacity, charge the OEMs with additional burden in their contracts. Much like we did years ago when we did not understand some new switchgear, we would actually give it to the OEM to say, provide us.
When we had a similar issue, when the privatization took place, the best way to get to speed was to have the OEM do not only the supply part of it, but also the installation and the maintenance part of it. So if you want to build up capacity in terms of skill set development, that's the proven way to do it in India, unlike other countries. Over.
Can I interfere here?
Please, sir.
That's a point, yes. The OEMs are now taking care of the charging in the depots and then operating the buses. Now, upstream connections, as Reggie was saying, that upstream connections and bringing the power into the depot is not the responsibility of OEM. Now, they are not even, willing to even think about it. Forget about bringing them into, kind of contract or something. They'll stay very far from this idea itself. Already we've been trying that. Now we are actually thinking at our intellectual levels that we have to bring in a third party to create another outsourcing third party who is going to provide this upstream connection and also maintain upstream connection and charge per kilometer to the STUs. That's the latest idea going around. Thank you.
I think I have, Mr. Suryakaran, is that who is going to bridge this with knowledge and capability in-house to both the upstream, that is the utility, and also knowledge and capability to the user, which is the transport corporation. How do you propose that we have this long-term arrangement? Because what you will get is perhaps a good start. But in the end, you need to see these C&I capabilities and power capabilities embedded in these organizations for at least one or two people who know the subject matter. So I park it as a question. I don't think we have an answer here.
No, Ravi, I think you need to be a little more specific. When you say CNI, which equipment are you referring to? Are you referring to power electronics associated with the EV chargers?
You tell my fellow, he'll drop you and come back.
Partly with respect to the EV chargers and also with respect to the electronics that's now appearing in the power system side as well.
No, see, anything which is upstream beyond the meter, which is supplying to the client, comes in the domain of the utility. That
Correct.
You cannot
Correct.
change the act. That's as per the Electricity Act.
Right.
Now, if you are referring to the EV charger, which is part of this domain of the OEM who is going to install it at the bus charging station, then that would be in the domain of the OEM who's going to do the bus charging part of it.
Ram, actually, I was coming into the wedge issue. The client, which is the transport corporation, must also have certain levels of minimum skill set to be able to specify, check, verify, and accept these OEM equipments, isn't it? So relying completely on the OEM is also not perhaps the greatest. And also the ability to write specifications that meets your requirement, which is in tandem with what is happening in that area, could be one. But I get everybody's point. I think everybody is saying that. But there is, Reggie, a holding point for you is how do you develop this capability and capacity perhaps going forward? Could be one action item for ISGF. The second comment I have, again listening to Mr. Suryakaran, was how come only a small minority of the buses are inner city buses? In fact, the Calcutta study showed that the lowest hanging fruits were actually to electrify the inner city buses because they were operating at very low speeds, B, they were not polluting inner cities, and C, the bus batteries could be made very low. So I'm a little surprised that bulk of the transports on the electric side is sitting in what we call the mafusel side of the bus transport operation. So anyway, that's an observation, but Reggie, that's something.
No, you got it wrong.
Other way
90% of the buses are
Okay.
inside the city, intra-city. Very few buses are from intercity, one city to another city. That is because no charging infrastructure on the highway. This is something which
agree. No. I heard is intercity as inner city, and therefore maybe I reacted.
No. Intercity.
My apologies. So we now have, in fact, about 5-6 minutes left, and I see a few questions. So maybe if Parul wants to put up those few questions, and then we can have another last closing round of discussions.
Yes, sir. So we have all our questions compiled, and I request Bala to please share the screen for the presentation with the questions.
Sir, two questions we have from one question. First question is from Mukesh Terry to Guha sir. Are you upgrading new installation of electrical network like DT transformers, feeders, upcoming e-buses, and should we consider smart charging impact and based charging impact on infrastructure upgradation?
Hello. Now, regarding this, hello, can you hear me?
Yes,
Yes,
we
sir.
can hear you, sir.
Now, regarding this upgradation of new installation of electrical network, as Mr. Ravi pointed out, that the installation of the electrical network for downstream, that is from this high voltage to the working voltage, and then afterwards, is going to be maintained, installed, and operated by the OEM or the operator. So it is totally their call, but we hope that they will have some upgraded and modern equipments which will be very much efficient and should be able to deliver properly.
Hope that they will do
And regarding this smart charging,
what they are doing.
and the other thing is,
That will
I
be
can't see it. Anyway, so we expect that the charging equipments that they will be using would be efficient enough and should go by the present standards and yield good results.
Next question.
Next question is from Yogesh Nama. That is compiling reason to go for fourth core mainly come from third harmonic, but here in study all harmonic was within limit. So would be interesting to know what else is contributing for higher current, thus higher temperature in neutral.
Okay, so let me take that on. It's a mixed bag of everything. The question is not whether the third harmonic alone is within limits. There are other electronic, for an electric utility, there are so many things happening by way of imbalance that is also causing a neutral current. So in the past, when we had three-phase supply only, those neutral currents were very limited. And based on the coefficient of what we call the star point, some were very, very strong and some are not strong, in fact. So the ones that are not strong see the neutral star point shift. And therefore, you get an unbalance, so to speak. Even a small unbalance causes the problem. So therefore, the question is not one of just third harmonics alone, but a utility feeds all various loads. And therefore, the question is, should we move into a four core? And I see good comments. I see CESC saying they've already got a four core. I see Ram Pillai, when he was serving with the Tata, saying he's got four core. So it looks like that leading thought has already been put to practice by a few utilities. Perhaps maybe others need to follow, or maybe the standards have not enforced it, so they're not forced to go. Because yesterday we had a conversation with another utility that Reggie was chairing, and it didn't appear that they had gone to four core. Okay, so maybe different people are on different wavelengths here. But the third harmonic is not the only one that causes heating in the neutral. There are other things that cause heating in the neutral as well, as because of the current magnitude that rising. That is actually going up thanks to other things that are happening in the utility. Okay, next question.
Sir, these are the two questions we have received, sir.
Okay. Then there was one other, by the way. I think there was one other question saying something to do with an RTO. I think it's now slipped. There was a person who asked the question. Do you have technical capable people within an RTO to manage EVSE equipment or something to that effect? But maybe
I can
Ram's
read out that
comments or
question.
others' comment, they have.
It is by Siddhi. The question is there any electrical engineer deployed by any RTO in India to pass an EV prior to registration?
Pass an EV means what? What do you mean by pass an EV? Is there a engineering test for EV?
Siddhi, if you can give a clarification.
No, you are asking pass an EV. What do you mean by pass an EV?
It could be, I'll tell you, when we had battery systems 10 years ago, we created what was called a client acceptance test. So we had a factory acceptance test, which was done as per standards. And then there were pulled out from the requirements were certain client acceptance tests, which the client viewed it over and above what the inspectors.
See, our RTOs are not doing it. It is done by ARAI. So they test and they do the homologation and give the clearance for a particular model of a bus or a car or a two-wheeler. And thereafter, those models with those certificates will get the RTO registration.
Okay.
That's a process. Every vehicle is not tested by a RTO for giving you a registration certificate. So or a vehicle registration number. That is not feasible. So the OEM first get it done by ARAI, and ARAI certificate for that model qualifies that to be registered by RTOs across the country.
Even CRT does that.
And,
Okay.
and I, yes, and I just
catch.
want to add one thing. I just want to add, yes, exactly so. PIRT, ARA, and ICAT. These three organizations are there who give the approval, and the manufacturer has the responsibility to upload it in the portal for each and every vehicle with specific chassis number and engine number or motor number or whatever. With respect to that, the concerned RTO upload and just validate the data, and then the registration is done. This is the present process.
Okay. I see there are no more questions in the chat as well.
There are two questions. Hello.
Sorry, are you?
Sir,
Bala,
there are
any
two
more
questions.
questions, or are we finished?
Yes, sir, there are two questions. What
Okay,
is
why
the
don't
charger rating of chargers in Kolkata, and what is the installation cost of each charger?
Cost, we may not be able to talk about it. That varies. It's a function of many things. The existing chargers are all 60 kilowatt and 120 kilowatt DC chargers, and the new buses which are going to be deployed, 1180 buses, they will have 240 kilowatt charger in the DC charger. That I already typed as answer in the chat box.
Yes, sir. And one more question: are we planning to establish new depots for?
The approximate cost of these 240 kilowatt chargers is around 26 to 27 lakhs.
Yeah, with volume it will come down, sir. With volumes now, the 240 kilowatt, not even 500 chargers we installed in the country. But when it get into several thousands, the price will come down. I guess it should be
maybe.
Yeah.
So I just gave an idea that it will be around 25 to 27 lakhs.
So what is the other question, Bala?
Are we planning to establish new depots for aggregated charging or upgrading each depot for megawatt power requirement?
It's a combination of both, most probably in most cities, because we cannot make a new depot where 500 buses can be charged outside the city and all the buses come to run on the different routes. So which is not practical. Buses need to run on a regular route where people are usually boarding. So the nearest depot, those buses will be charged to the extent possible. So there are different ways. The bus company, the city municipality, and the electricity company all need to plan. This is the new normal, which was not there in the past. Bus company could do what they want to do. Electricity fellows never bothered about them, and the bus company never bothered about the electricity company. But both need to now work very closely, and the municipality. And some places where we've been seeing is that you may need to existing bus in the inner city where there is no space. Maybe you may like to go multi-layer so that charging facilities can be created multi-layer. So those kind of things we need to look at it. Renovation of the bus depot. Maybe the money for that may come by commercializing the upper floors. Lower floors, like railway stations, are now being modernized by commercializing the extra space. Same way, some of the big bus depots which you have in Calcutta and other Bombay and other cities, if you completely renovate the basements and the lower basements and the wherever some of the floors where can be for the bus charging and rest of them can be commercial office and other commercial spaces, all that possible. Even public charging station can be also be created where people can come and charge their car, two-wheeler, three-wheeler, etc. All that possible. The business models will emerge. In a way, people will have more ideas, and when the sector opens up, it will happen.
So I think we've got a good discussion. We also talked of flooding. In fact, it reminds me, I was in Taipei, Taiwan. the latest thought around these in flooding to prevent, short circuit due to flooding is to put a water sensor 1/3 of the wheel up from the ground, which I thought was very interesting from an India perspective to reflect that if your water level goes higher than, let's say, 1/3 from the bottom, the whole thing just shuts down. In fact, the whole vehicle just shuts off. And it actually requires an OEM to come and, restart or reset that process. So something that India needs to think about because of this
Ravi,
flooding.
there's one point here. That still doesn't allow prevent the water from going above the charger.
Correct. I'm not talking of charger, I'm talking of the buses here. The charger, hopefully they can put a bigger pedestal, if you will. But it was interesting to hear where the OEM industry is talking about for safety. And that safety could become a huge problem, in fact, for the customer, depending on the type of issues in which your vehicles run. Something to think about. Okay, so I see that it's a little past our time. Let me now turn it over to Reji for his vote of thanks. And thank you to the panel for an interesting discussion. Thank you to all the people who asked the questions. And this is just the beginning of the journey.
Won't take much of your time. So thank you for the wonderful discussion. Thank you, Ravi sir, for moderating the session. Thank you to all the panelists and more to all the participants.
Thank you.
Sorry, my computer died, so we came for a meeting in some other place.
Okay, so Reji is off. Okay, so let me just continue. Or Rina, if you want to close, I think that will be appropriate as well.
Hello, can you hear me?
Yeah, now we can hear you. Now we can hear you.
Sound Anand, just. Yeah, can you hear me now?
Yeah, I can hear you now.
Let me just switch on the video also. Yeah. Yeah, sorry, my computer died. So this Anand's computer. So thank you, big thank you to participants of the study. And we also thank Mr. Kiran Reddy, and we look forward to take.
We have lost you, Reji. We have lost you. Can't hear you. Cannot hear you.
It automatically went to mute. I said we look forward to taking the results of the study and learnings to all the bus companies wrote for undertakings along with the ASRTU, and we'll be happy to conduct training programs and capacity building programs for them and educate them. And we look forward to working with the WBTC in rollout of the 1180 new fleet, one of the largest fleet which will be operationalized in the country. And this is going to change everything in the electric mobility. 50,000 buses coming in next 3 or 5 years is going to be a paradigm shift in not only for the transport sector, but also for the electricity distribution companies. For them, the bus companies becoming an important customer who need to be serviced with special attention. So this is a new chapter in the electric mobility and electricity distribution business, and we look forward to working with all the stakeholders. Thank you for everybody for your participation. The report will be in ISGF website next week, and we'll also early next week we will also mail it to all the registered participants of this webinar. Thank you very much. A good day, good evening, good night.
Thank you. Thank you all.
Thank you to all our speakers and our participants. So I would request all the participants to kindly join us for the polling. This is asking about how was your overall experience of this webinar, and will you be attending future ISGF webinars? The links to cast the votes are posted in the chat box. You can quickly click on the link and cast your votes. So thank you again to all our esteemed speakers for joining us and sharing their views and thoughts and knowledge about EVSEs and about safety mitigation. And I would also like to thank all the participants. Without them, this would have not been the successful webinar. So thank you so much, everyone.